Hello students, welcome to my channel Engineering Education. Please subscribe my channel for engineering related problems solution. In this video we are going to discuss example 14.1 from chapter number 14, Refrigeration and Heat Pumps, from the book Applied Thermodynamics by Eastop and McConkey. In this example we have given that a refrigerator has working temperatures in the evaporator and condenser coils of minus 30 degrees centigrade and 32 degrees centigrade respectively. What is the maximum COP, coefficient of performance, possible if the actual refrigerator has coefficient of performance of 0.75 of the maximum? Calculate the required power input for a refrigerating effect of 5 kilowatt. So we have given the information, and those are temperatures. Temperature T1, which is minus 30 degrees centigrade. So converting it to Kelvin, it will become 243 Kelvin. Also temperature T2 is given, which is 32 degrees centigrade, and converting it to Kelvin it will become 305 Kelvin. Also we have given that the actual refrigerator has a COP of 0.75 of the maximum COP. So we can say that COP of refrigerator, that is the actual COP, is equal to 0.75 maximum COP of the refrigerator. So we are required to find the maximum COP, that is maximum COP of refrigeration, and second we have to find and calculate the required power input, that is W dot. Also we have given the refrigerating effect, that is Q1 dot, and it is 5 kilowatt. We discussed this thing in the previous videos as well, that simple Q represents the heat and its unit is joule or kilojoule, while Q dot is basically representing the heat transfer, or in this case this is the refrigerating effect, and its unit is watt or kilowatt. Similarly, simple W represents the work done, and W dot represents the power. Simple work has the units of joule or kilojoule, while power has the units of watt or kilowatt. Now coming to the solution of this problem, this example is solved in the book as well. We are going to discuss it just for the understanding of the students. So this is the COP in terms of temperatures for refrigeration system, and this is basically the maximum COP of the refrigerator, T1 by T2 minus T1. This expression is derived in the text in chapter number 14. T1 is 243 while T2 is 305 minus 243. So the maximum COP for this system in the example is 3.92. Also we have given that the actual COP is 0.75 times of the maximum COP. So actual COP of refrigeration is 0.75 times of the maximum COP, that is 3.92. So the actual coefficient of performance of refrigeration is 2.94. Now, second, we have to find the power input required. So for that, using the basic definition of coefficient of performance of refrigeration, that is equal to the refrigerating effect to the input power. This is basically Q1 dot and this is W dot. So Q1 dot is 5 kilowatt and we have to find this W dot, and this is known to us. This is actually the actual COP of the refrigeration. So rearranging this expression, so it will become W dot is equal to Q1 dot by COP, that is the actual COP of refrigerator. So 5 divided by actual COP is calculated, that is 2.94. So the required power input is 1.7 kilowatt for this refrigerator. So this is the solution of example 14.1 which was discussed. Thank you for watching. Please subscribe my channel for upcoming videos. Thank you.